Hi everybody, welcome to my session. Today I'm going to be talking about ECS networking modes. I'm going to be focusing on AWS VPC and how you can use that to still get a lot of containers per instance. We're going to look at maximizing your workloads on ECS. So first of all, a little bit about me. Um, I'm Rick Harvey. I'm a staff cloud architect at Do It International, one of the sponsors of today's event. So we're very proud to be helping out and doing our piece here for the community. I'm the former AWS technical evangelist and solutions architect at AWS. If you want to reach out to me, I'm on Twitter at Rick_Harvey, and my GitHub and Docker Hub here as well. So a little bit about me. I also wrote S3R.io. It's one of my favorite projects. It's a serverless and databaseless, yes, databaseless URL shortener. So go and take a look at that if you want to have a look at what I've been doing. Okay, so let's move into the talk. First of all, I'm going to give a little bit of a high-level overview of ECS, a 10,000-foot view of ECS, what it is and how it works. So ECS is an AWS managed control plane for orchestrating and scheduling containers. And I'm going to talk about ECS and not Fargate. I'll explain the difference in a moment. ECS, you bring your own instances. So you run some EC2 instances. These are optimized instances for ECS. You start them up with some information in the EC2 metadata in the cloud init script, which tells it which ECS cluster to connect to. Once they're booted, that resource becomes available, and Amazon ECS can then place workloads onto those instances. So workloads come in the forms of tasks and services. For those of you used to Kubernetes, a task is a pod. Basically, what a task is, it's a definition of up to 15 different containers and how they run and how they're linked and how they're related to each other. They're closely coupled containers that you need to do. When you have a task, if you just run that single task, it runs once. But what a service does, service is responsible for placing that task multiple times. So let's say I'm running a website and I want to go highly available. So I want to run 3 copies. In the service definition, I tell it to run that task 3 times. The service is then responsible for monitoring the health of those containers, those tasks, and making sure there's always 3 copies available in my cluster. It also does things like connects those load balancers, application load balancers, the preferred way to do this. When you go to place a service, a task via a service rather, you have placement strategies. Placement strategies are ways of saying how you want the containers to be spread out within your cluster. So in this example here, I've used something called availability zone spread. And that's what that's doing here is it's making sure that 4 tasks I've asked it to run are equally spread out across the 2 availability zones I'm using. So in this case, I've placed a workload on each one of those instances. There's other packing algorithms. I'm not going to go deep into them at the moment, but some of them are bin pack. Bin pack ensures that you get the maximum amount of containers crammed onto one instance, just to make sure that you get the best value for money out of that container instance, and you don't waste any CPU or RAM on there. There's also something called placement constraints. Now, placement constraints lets you do things like specify a certain instance types for running. So in this demo here, I've just shown that a P3 large P3 2XL, sorry, is running my particular workload. This workload needs a GPU, so there's no point in running it on the C5 large. So in my placement constraint, I've specified the instance. It's going to use AZ spread and it's running on. You can also do other things by saying, I only want this workload to run in a particular availability zone. You can also use placement constraints with custom tags that you place. Okay, so that's ECS, a high-level overview. Those of you wondering about Fargate as well, it's exactly the same, but you don't bring your own instance at the bottom. So we get rid of all these things down here, and you don't need to. Just a control plane, you give it a container, Amazon uses something called Firecracker to spin up your container. Okay, now let's get a little bit deeper. Let's talk about the networking modes within ECS. So when you run a task, a service places that task on an instance. The instance here is highlighted by the orange box, and the instance has an elastic network interface attached to it. So the networking modes for this task could be none, and this way it won't have any access to or from the internet. And the nice thing about this is if you've just got workloads that are on disk that you want to bring a task up and process, then write back, this is the most secure way to run. The next networking mode is host, and this is basically port mapping. So you bring a task up, let's say you run that task on port 80. That task can have a one-to-one mapping the host network interface. So on the host network interface, port 80 is opened, and you come through and you can access your. The problem with this is, with task definitions, if you specify the mapping is port 80 to port 80, only run that task once. So it makes it a little bit tricky to do like that. Another method is bridge, and this is very similar to how you run Docker on your desktop. You have bridge mode, there's a Docker 0 interface. If you're on a Mac or Windows, this is kind of obfuscated and hidden because you have a virtual host running. But within that, there is Docker 0 network. This just shows up just like ECS. Yet again, you've got limitations on how you map. But within the actual Docker network, you've got multiple IP addresses for different tasks. And then the final one is AWS VPC mode. Now, this makes a lot of things a lot easier. So the task gets its own network interface. It gets its own ENI. And through that, you can have a one-to-one relationship. You can open any port you want on there. You don't have contention. You also get a high speed, low latency, low jitter access into any services from that task definition, without contending with any other container at host. So if your task is particularly network heavy, you're not going to impact the running of other containers. And this is one of the preferred ways to run. And in fact, if you're running Fargate mode, that's the only option you get. So I'm going to talk about a bit of an example task here. I've got a primary task, half a CPU, a gig of RAM, and a helper task, which is only 0.1 of a CPU and 128 mega RAM. Now, I want to place two of these primary tasks. So I want to place two of them running, and I want as many helper tasks as possible. So let's put N for that value there. Now, let's go and have a look at one of these C5 larges I showing that was connected to my cluster. C5 large has 3 elastic network interfaces by default. So that means I've got a primary network interface, and that's for the host to use, so it can pull down the Docker images, back with the ECS. And then 2 tasks are going to run, and they're each going to get their own elastic network. In this case, I can run my 2 primary tasks. So I've got 2 virtual CPUs and 4 gig of RAM. Well, that means I've got a little bit of a wastage here. I'm only using one of my virtual CPUs, 2 gig of RAM. So I've got a 50% waste on the instance. This isn't particularly cost effective. So what can you do? Well, it's ENI trunking. ENI trunking is a feature you have to switch on. And when you do so, you get a primary network interface and a trunk interface connected at C5 large instance. Now, don't worry, it doesn't mean you can only run one task now. What actually happens is you now run 10 tasks because you can attach a further 10 elastic network interfaces. That's C5 large. So in our use case, I can run 2 primary tasks and I can run 8 helper tasks. So that's really, really good use. And if we look at the total usage of that machine, I'm now using 1.8 virtual CPU and 3 gig of memory, but a lot less wastage. So I'm getting better value from that with ENI trunking. If we look at that in some comparisons with costs, My one C5 large there is running $140 a month, and that's got plenty of overhead on it. Now, if I was to break this down, I've gone to a C5 large there. You could do M5 large as well, obviously, but I've stayed with the same. But in order to run the 8 helper tasks there, I had to break that down onto T3 smalls. T3 smalls, pretty cheap to run, and it only added $83 to the bill. So not a huge amount. If you're doing this at scale, that sort of thing soon adds up. And also don't forget, there's 5 extra instances you have to run, patch and manage. So in the AWS shared responsibility model, AWS look after that managed control plane of ECS, but all the instances underneath, that's your responsibility. After those, they're okay. Got to do OS updates, make sure the Docker agents are latest, TS agents are latest. Well, that's your responsibility. Firewalls as well. So the T3 small is actually the smallest of the family to support 3 elastic network interfaces. So that's why I was squeezing those instances. Okay, how do you enable this? So enabling ENI trunking is quite simple. First of all, you've got to make sure you've got the linked IAM role in your account. And I'm going to give you a worksheet after this in GitHub. Just download and try this at home. So you create a linked IAM role. If you've already got ECS, you may have this role created, so don't worry if you get an error back from the company. And then the easiest way is to really enroll the account, or you can actually enroll an IAM role. If you do the IAM role enrollment, this is quite useful because what it does, it means that when you start a C5 instance, you can opt whether it's going to have the IAM role attached that gives it extra network interfaces, or if you want to keep it separate and just run it as default with 3 elastic network. Once you've curated it, you do this with from the command line. This will actually list your ECS clusters and tell you which ones have got their trunk enabled, and it'll give you some details about trunk IDs. There's a few caveats to running this. You can only run the Linux variants of the Amazon ECS optimized AMI. The Windows ones don't work at the moment, as far as I'm aware. You've got to make sure that if you want to take advantage of the trunking, that you once you've enabled it on your account, only instances started after that will benefit from having those extra network interfaces. Ones started before won't get extra network interfaces. And there's some strange idiosyncrasies when you're launching a new cluster instance. You get some strange things holding in registering, and that's just why the network interface is trunk. It doesn't take very long, and it's hardly noticeable. You might see a little bit of difference to how you're used. Okay, let's have a quick look at instance types and the benefits you get from it. So I did the C5 large, so you was limited to running 2 tasks on that host. With ENI trunking enabled, you get 10. And if you look down here, when you get to the C5 18XLs, that's a superb increase there. You go from running 14 task instances on that machine, being able to run 120. It's a real dense packing of containers. And as long as your containers aren't using too much CPU and RAM, you can fit 120 Docker containers on there if you want to. This works with C5s, M5s, P3s, R5s, and A1s at the moment. These are all instance types that actually use the Nitro hypervisor developed by AWS. So this is separate silicon that runs and controls the hardware underneath, get better density. AWS. If you want to go and jump to the documentation, there's a URL at the bottom of the screen here that'll show you where these instance links, these instance types, and their increase are. Right, it's time for a demo. I'm going to show you this in action. So here in the demo, I'm running a cluster in ECS. We drop back to actually have a look at the cluster view here. I've got one running instance, and if I pop over here and lift myself up, see, one container instance there. I'm running one service and two tasks. I'm only using 25% of the CPU utilization and 10% of memory. So I'm not using everything. If we dive in this cluster, have a quick look at the task, you'll see that I've actually told it I want 6 versions. I'm only running 2. And this is because if we open this up a little bit further and have a look at the events, we've got this error message here saying the task was unable to be placed because no container instance met all of its requirements. Basically, I've only got one EC2 instance and it's run out of networking. So resource ENI is the error it's getting here in the logs. Now, if I drop to the console quickly, on here, just run and show you that currently I've got no ENI trunking enabled. Cool. So the first thing we really need to do is switch that on. Come over here and paste this in here. So this is going to switch on ENI trunking in my account. And still you'll notice that ENI is not enabled. And that's because that C5 instance was started before I on my. So what I'm going to do now is, if we drop back into the browser a second, I'm going to go over to EC2 and I'm going to launch a new C5 instance. So if we pop in here and I'd say running instances, launch a new one. Now in here, I'm just going to put in the AMI ID to get to the ECS optimized one. That's a AMI. Confused myself there a little bit. We select this here. And I'm going to narrow this down just to our compute optimized again. So I'm going to find my C5 large, exactly the same instance type. We go on, I'm going to make sure that I'm in the right VPC to start with. I'm going private 1 for the subnet again. Scroll down here, IAM role is my standard ECS role. Default one that gets created when you start running ECS. And then down in metadata here, this is where we actually give the instance some information when it starts running and tell it to join the demo cluster. So you can see here that gets echoed into a config. Add storage, we're just going to select all the defaults. I don't want any tags. Security group, I'm actually going to drop SSH off. Now I do this because I don't like SSHing into my instances. If I was configuring this for production, I might consider putting on there the service agent to let me go in through the ECS console dashboard, systems manager, and open a shell that way. But this just reduces that attack vector on your machine a little bit more. Also makes your security groups. So C5 large running, I'm going to launch it. Because I've not got SSH open, I'm going to say proceed without a key pair. Like I say, systems manager would get you around all these kind of problems if you do it in that way. I'm going to have a look at this instance. It's going to be booting up now in its pending state. When I drop back now to our ECS container service, what we're doing for here, move myself up again, we're going to wait for this container instance count here, move up to. As that container comes up, that will happen. Here we go. We've now got 2 container instances running down below. That's come up, it's registered, ready to use resource. So in theory, our machine, our service should be ready to run. If we dive in and have a look now, it sometimes takes ECS a little bit of time to catch up. So we're going to force this point. I'm going to go in here, I'm going to update this service. And I'm going to take it one step further. I'm going to say I want to run After all, folding at home is for a cause. Keep going through, accept all the defaults, and the service is updated. So the scheduler is now going to go and try and place this workload. What we'll see starting to happen, get more containers started. I'm going to drop back to the view, in, wait for these tasks to come up. Now got 6 pending tasks. Here we go. If we have a look over that way, we'll see that we've got 8 running tasks, 1 service and 8 running tasks. Before we had 1 instance and could only run 2, but now we've got 2 instances. We can run 8, and that's happening because of the magic of this ENI trunk. So if we just have a quick look back on the shell, and you see before that we had no attributes to ENI trunks. If we run that command again now, we'll get this returned. Pop this up in the middle of the screen for you. You can see that I've got a value, I've got an ENI trunk, and it's linked to a particular container instance. There's only one of them there. From now on, any C5 that I launch will get that same benefit. We have to run more containers. So this is how you pack in more containers, the same instance. Yes. I really hope you enjoyed the talk today, and thank you very much for coming. Speak to you later.